Great, we have the vertices of one of the diagonals of a square are located at -3, 4 and at 2, -1. Enter the values and select a phrase to describe the location of the other vertices of the square. So we're having to pick two coordinates, and then it says because those points make the diagonals, and we have to pick a characteristic. So anytime you are asked to put points on a graph, you want to use your graph paper that is on the back of your work folder. So the first thing I'm going to do is I'm going to plot these 2 points. Okay, these are my 2 points. So the next thing I'm going to do is I'm going to think about what it said. It said this was a diagonal of a square. The diagonal of a square goes through the square. So if I were to just sketch a square out in my head, this is what my diagonal might look like. Some things I want to remember about the diagonals of a square: if I drew them both in, they cut each other in half and they meet at right angles. So if I could find the middle of this, that would help me sort of figure out where the other points are. Okay, I could also think about what the slope is of this line. So this line goes down, down 1 over 1, down 1 over 1, down 1 over 1, like that, and that's my pattern. So my other slope, since they're perpendicular, would have to go the opposite direction. It would have to go up 1 over 1, up 1 over 1, up 1 over 1. And I know it's going to have to pass through the middle of this. Okay, now that part might be a little bit tricky because it's not going to fall right on one of these lattice points. I could sketch a square out. So I have scratch paper, right? And if I wanted to sketch a square, I could sketch a square like that. Okay, and if I put my diagonals in, then I could see that this diagonal does go up 1 over 1, up 1 over 1. So the slope of this line is correct. So that must mean that my points are in the right spot. I could double check and make sure that these are intersecting at the midpoints. But I think I can eyeball this one and figure out the coordinates pretty well. So this coordinate over here would be 2, 4. And this coordinate over here would be -3, -1. Okay. So now I have to put those in my answer sheet. So I would have a 2, 4, and a -3, -1. And then I have to read through these choices to see which makes sense. Okay, we said important facts here we know are that they're perpendicular, they make right angles, and that they cut each other in half. They're also going to be the same exact size when you have a square. So the word that means the same exact size is going to be congruent. So I know this word's important. The word that means they meet at right angles is perpendicular. So that one's definitely important. So this first choice is the only choice that's true. So I'm going to pick the first one. Okay. Now some important things to think about is that you want to think about your other quadrilaterals because you're not sure which one's going to be on the test, and this is dealing with this square. If you think about your rectangle's diagonals are congruent. They're the same size, but they're not going to be perpendicular. So if this were a rectangle, we would say they're congruent but not perpendicular. Another parallelogram that you might deal with is a rhombus. Now a rhombus is when all the sides like this are the same, but the corners aren't 90 degrees necessarily. They could be, that makes it a square if it is. If I draw these diagonals are not the same length. We can tell this one is a lot shorter than this one. They do still cut each other in half, and they meet at right angles. So if it were a rhombus, we would say that they're perpendicular but not necessarily congruent. Okay? So those are some important facts you might need to know because you never know if they're going to ask you about a rectangle, a rhombus, or a square in a question like this.